So in the last video I introduced you to electric fields, and in that case we were actually dealing with what is considered a non-uniform electric field. And non-uniform electric fields arise when we deal with the idea of point charges, or maybe like a round conducting sphere. So if I were to draw the electric field lines for around a positive charge like this, remember they point away from the positive and towards the negative, so we'd end up having these rays that sort of radiate out from the charge. Now if I were to have like a negative charge, again that would be similar but just in the opposite direction. And so they're non-uniform, meaning it's not parallel. But we can have instances where we have a uniform electric field, right? Now, in this case also, we have, if you are here, you're here, or you're here, we know that your electric field magnitude is going to be different relative to your distance away from this position. We can also have, though, the idea of uniform electric fields. And if you've done the Charges and Fields lab, then you have seen an example where that actually occurs. Like I made you actually make what is sort of a parallel plate. But essentially a uniform electric field looks like this, right, where we have all parallel lines. And within this field, no matter where you are, the electric field would be equal in magnitude. So if this was an electric field of 20 newtons per coulomb, that means here, 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 no matter where you are, you're experiencing 20 newtons per coulomb as the magnitude of the electric field. So how does this actually arise? How do we get this? And so one of the examples is something called a parallel plate, and these are actually pretty common electronic devices. They're also called capacitors, where you have one plate that has stored up a bunch of negative charge and another plate that has some positive charge. And this is what I had you do in the Charges and Fields lab. So I made you have a big column of negative and a big column of positive charges, and you could sort of see the uniform field that arose in between the two plates. So the direction here would be to the left, right? And you'd end up with all of these parallel lines. Now towards the edge, you'd start to get some weird things happening because of the open space here. But within, right in between the plates, you have what is a uniform electric field. Now, in the next few examples, in the next videos, I'm actually going to talk about, what happens if we were to place a charge into this field. What does it mean in terms of energy? What does it mean in terms of volts? And what does it mean in terms of motion of that charged particle?